today's video, we are going to cover distance on the coordinate plane. Our learning targets for today are I can use the Pythagorean theorem to find distances between points in a coordinate plane. So finding distance on a coordinate plane. Sometimes finding the distance between points on a coordinate plane is as simple as looking and counting the numbers of units, like in graph A. If I have a horizontal line, I can simply count how many units there are. So in graph A, it'd be 3 units. Other times, we might need to find a diagonal distance, like in graph B. So notice in graph B, I have this diagonal distance. I can't physically count how many boxes that actually is. So in order to find a diagonal distance on a coordinate plane, we can create our own right triangle and use the Pythagorean theorem to calculate the distance. So for instance, if I create a right triangle here, notice that vertical lines and horizontal lines will be perpendicular, so I know that's a right triangle. Then I can find my two side lengths and then use a squared plus b squared equals c squared to find my hypotenuse. And your diagonal distance would represent the hypotenuse, or c. Putting this into an example, notice if I connect points A and B, that'll give me a diagonal distance. Now, if I create my two legs, this gives me a right triangle. Now I can figure out what my horizontal leg distance is by counting the boxes. Notice there's 4 boxes, so this would be a length of 4 units. My vertical distance is a length of 5, so this length is 5 units. Now I can use the Pythagorean theorem. A squared plus b squared is equal to c squared. And I remember I'm trying to find my hypotenuse. We'll call that c. So if a is 4, then I'd have 4 squared plus b squared could be 5, so 5 squared. That's going to be equal to c squared. 4 squared is 16. 5 squared is 25. That's equal to c squared. 16 plus 25 is 41. Now, in order to get rid of my square, I do the inverse operation, which is the square root. So c will equal the square root of 41, and the square root of 41 is 6.4. So c is 6.4 units. Looking at problem 4, so I want to use my graph and the Pythagorean theorem to find the distance between the points. This time the points are not plotted for me, so I need to plot my points. Remember, ordered pairs are x and y. X is my horizontal distance, which is left and right, and y is my vertical distance, which is up and down. So negative 6, 1 will be right here, and then negative 4, 5 will be right here. Again, if I create my diagonal distance and then create my legs, I can use the Pythagorean theorem to figure out what my hypotenuse length is. My horizontal distance has a length of 2. My vertical distance has a length of 4. So again, using the Pythagorean theorem, a squared plus b squared is equal to c squared. If we call a 2, 2 squared plus b would then be 4. 4 squared is equal to c squared. 2 squared is 4. 4 squared is 16. That's equal to c squared. So 20 is equal to c squared. Again, taking the inverse of my square is the square root. So c will equal the square root of 20, and the square root of 20 is approximately 4.5. So my hypotenuse length is 4.5 units. Looking at number 7, find the perimeter of the trapezoid. So notice I have a few horizontal and vertical distances, and then I have a diagonal distance. So my horizontal and vertical distances I can easily find. Doing that will give me a top length of 6, a vertical length of 8, and then my bottom horizontal length of 12. Now I need to find my diagonal distance. If I drop a vertical line straight down, that creates my right triangle. Notice this new vertical line has a length of 8. My horizontal line has a length of 6, and I'm trying to find my length c. Now I can use the Pythagorean theorem to find c. So 6 squared plus 8 squared would equal c squared. 6 squared is 36. 8 squared is 64. That's equal to c squared. 36 plus 64 is 100. That's equal to c squared. Again, getting rid of my square, I take the inverse, the square root. So the square root of 100 is 10. So c is 10. Now that I know C is 10, I can replace C with my length of 10. Now I can find my perimeter. Remember, perimeter is all of my sides added together. So my perimeter of this trapezoid would be 12 plus 8 plus 6 plus 10, which is 36 units. So the perimeter of this trapezoid is 36 units. In this lesson, we learned to find diagonal lengths in the coordinate plane, create a right triangle, and use the Pythagorean theorem to find the length of your diagonal. That's a wrap on this video. We'll see you in the next one.